Hello everyone, this is Dr. E, and for today we're going to be working on some problems about trapezoids, specifically on the median or the mid-segment theorem, also known as the midline theorem in geometry. From our previous lessons, we know how important it is to use the conditions, properties, theorems in geometry to be able to understand our polygons that would help us in solving some of the problems involving the measurements of the shapes that we are working on. And for today, that's what we're going to be discussing on this special parallelogram, which is one of our favorites in geometry, which is trapezoid. So we're going to be working on a special part of a trapezoid, which is the median of a trapezoid. And according to the definition, the median of a trapezoid is the segment joining the midpoints of the legs. Now, the line segment that we're going to be producing here is parallel to the basis of this particular trapezoid, or trapezoid in general. So let's draw our trapezoid so that we'll be able to understand what the definition of the median is according to this lesson that we're working on today. So you're seeing a trapezoid, and according to our condition, you don't need to have both opposite sides of your quadrilateral to be parallel for it to be considered a trapezoid. You just need one pair of opposite sides to be parallel. In this case, we are seeing that our top horizontal line and the bottom horizontal line are both parallel, and the sides, or the legs as we call it in trapezoid, are non-parallel lines. So what we're going to be using is to illustrate the definition from verbal to visual. So we have here the midpoint of the first leg, which is halfway on the length of our first leg. And if we're going to measure the second leg, so this is obviously longer than the other leg, but if we're going to angle it like so, we'll be able to see that the midpoint of leg 1 and leg 2, if we connect it, it will produce a line segment that is equidistant to our bases for base 1 and base 2, and also parallel to our bases. So this is basically what the median of a trapezoid is according to the definition that is proven in our visual in what you're seeing right now. And this is what we're going to be using in our measurements for our trapezoid for today, specifically for our mid-segment or midline. So speaking of midline and mid-segment, we're going to be formulating a formula that will help us measure the mid-segment or the median or the midline of our trapezoid. So according to the definition, to be able to figure that out, the segment joining the midpoints of two non-parallel sides of a trapezoid is parallel to the basis of the trapezoid, which we are seeing right now. Let's call it line segment EF, and that is the first part of our midline theorem. And the second half of the midline theorem is telling us how to find the measurement of EF, which is its length is 1/2 the sum of the measures of the bases. So how are we going to formulate the formula using our definition? So let's find the measurement of line segment AB, which is our top base, and let's find the measurement of the bottom base, which is line segment DC. So what we can do according to the definition is we can find the measurement of our midline by taking the sum of the length of the top base and adding it to the length of the bottom base, and the combination or the sum of those two line segments, which is shown in this particular visual, we can see that the midpoint of the sum of our two bases is basically the actual measurement of our line segment EF, which happens to be our midline or mid-segment. So this is how we're able to formulate how to solve for the measurement of our mid-segment EF by using our trapezoid. So to find the measurement of EF, half of the sum of base 1 and base 2 will give the value of the mid-segment that we are looking for. So let's call it half of base 1 plus base 2 is equal to the midline or the mid-segment, and this will help us in answering problems involving the mid-segment or midline of our trapezoid. So let's use our formula, which we have just seen and derived based on the general form of a trapezoid. So in this case, we have a specific trapezoid ABCD, where AB is parallel to CD and XY is connecting the midpoint of legs AD and BC. Now, there's too much letters, too much symbols that we are seeing on the first part, so let's just draw it so that we'll be able to understand it better. So this is our trapezoid, and according to our information, we have trapezoid ABCD, wherein AB, which is the bottom base, is parallel to the top base CD, and XY is connecting the midpoint of the legs, which is CD, CB, and DA, and it has its specific measurements given to us. And in this case, line segment AB is 7x plus 15, which is not an actual measurement, but a description, specifically an algebraic expression, 7x plus 15. And we also have the measurement of the top base, which is 2x plus 4. But the measurement of our midline is a numerical value, which is 23 units. And what we need to do is to find the value of x in this particular trapezoid. So let's visualize it better by labeling our segments. Segment AB is 7x plus 15. Segment CD, or the top base, is 2x plus 4, and the midline is equal to 23. So in this case, since we have a trapezoid and we have a median or the mid segment, we can use our formula for finding the midline so we can solve for the value of x in this trapezoid. So let's use our algebra skill to find the value of x by using our formula, half of base 1 plus base 2 equal to the midline, to formulate our equation that will solve for x. So let's start with base 1, which is 2x plus 4, and let's add it to base 2 according to the formula, which is 7x plus 15. Now the sum of the two bases, if we take half of it, or multiply it by 1/2, it will equal to the base, it will equal to the median, which is equal to 23 units. And now we are seeing our algebraic equation. And since we have the value of x that we are looking for, let's use algebra to find the value of our x. So we have 1/2 of 2x plus 4 plus 7x plus 15, which is equal to the midline, which is 23. And now all we need to do is to simplify our equation using our algebra skill. So we are going to be combining like terms. So 2x and 7x is equal to 9x. And 4 plus 15 is equal to 19. And we will take half of it so that it will equal to 23. Now we know that we have an annoying fraction right here, and we know in algebra to be able to get rid of a fraction, just multiply both sides by its reciprocal, and the reciprocal of 1/2 is 2. So let's multiply it by 2 so that we can only have 1 right here, which is equal to 9x plus 19 equal to twice of 23, which is 46. And from here, all we need to do is to subtract both sides by 19, so that we can find the value of 9x equal to 46, or the difference between 46 and 19, so that we'll be able to find the value of x that we are looking for. So our x value will end up equal to 9x equal to 27, and we know that if we divide both sides by 9, x is now equal to 3. So this is now the value of x that we are looking for based on the formula that we have formulated from our previous slide. And now that we have our x value, we're done with our problem. But since we want to actually find the measurements of our bases. So let's plug in the value of 3 to base 1. So 2x plus 4 is base 1. So 2 times 3 is 6 added to 4. Base 1, or the top base, is equal to 10 units. The median is equal to 23 units, which is given in our problem. And the bottom base, which is 7x plus 15, using our x value of 3, 7 times 3 is 21, added to 15, will have 36 units. And you will see that the top base, the median, and the bottom base, their actual measurements corresponds to the definition of a trapezoid and our bases. So the smallest measurement is the top base, the biggest measurement is our bottom base, and the median is equal to 23. And according to the formula that we use, by using it correctly, we'll be able to solve our midline. So let's see and check if our formula will work for every trapezoid that we are working on, given its mid-segment. So base 1 is 10 and base 2 is 36. When we add that up, 10 plus 36, and take half of it, it should equal to 23, which is true because half of 46 is indeed 23. Therefore, the formula that we have just formulated from the definition of our median and the midline or mid-segment theorem, we can use it in any trapezoid and median in a geometry problem that you are going to be working on in your homework or in your quizzes. So our Numberbender challenge for the day is for you to use that new skill, the midline theorem or the mid-segment theorem, to solve for line segment CD. So you're given the value of your bottom base, you're given the value of your mid-segment XY. Now, how are you going to find the value of the top base using the formula that we have just discussed in this lesson? So, comment down below. Let's see if you can answer or find the measurement of CD based on the information that we are seeing in our trapezoid. And this is our lesson on the mid-segment theorem and the median and how important it is in finding the measurements of some of the parts of our trapezoid. And in algebra or in geometry, to be able to understand shapes better, you need to know your theorems and you need to understand how theorem works and the formula that you are using associated to the shapes or polygon that you are solving. This is Dr. E, and see you again next time. Bye!